In this example, we're asked to find the volume of the solid under the plane x minus 2y plus z equals to 1, and above the region enclosed by the line x plus y equals to 1, and the parabola x squared plus y equals to 1. We can set up the integral as a type 1 or a type 2, but in this case, let's work with a type 1 region. And to do that, we'll first of all need to solve two equations that bound the region with respect to y. So from the first one, we'll have that y equals to 1 minus x. And from the second one, we have that y equals to 1 minus x squared. And if we equalize these two to find the intersection points, we'll have that 1 minus x equals to 1 minus x squared. So that gives us that x squared minus x plus 1 minus 1 equals to 0. So that gives us that x squared minus x equals to 0. And if we factor x, we'll have x times x minus 1 equals to 0, which gives us that either x equals to 0 or x equals to 1. So from that, we get two intersection points. The intersection points are 0, 1, and 1, 0. And if we sketch now the region D, we have that the region D is bounded by the parabola y equals to 1 minus x squared and the line y equals to 1 minus x. And the two intersection points are the point 1, 0 and the point 0, 1. Now, in order to set up the type 1 integral, the upper boundary will be the parabola y equals to 1 minus x squared, and the lower boundary will be the line y equals to 1 minus x. So we have, this is the upper boundary, and this is the lower boundary. And also, x is between 0 and 1 with 0 and 1 included. So therefore, the region D is the set of all points x comma y such that 0 is less or equal to x and less or equal to 1. And 1 minus x is less or equal to y, and this is less or equal to 1 minus x squared. So here we have the lower boundary, and then this is the upper boundary of y. Before we set up the integral, we'll have to take the equation of the plane and solve for z. So we have that x minus 2y plus z equals to 1. So that gives us that z equals to 1 minus x plus 2y. And we're now ready to set up the double integral that gives the volume of the solid, which would be equal to the double integral from 0 up to 1, and the integral from 1 minus x to 1 minus x squared of 1 minus x plus 2y. So this is the z, that times dy dx. And this is equal to the integral from 0 up to 1. And if we now integrate the inner integral, we'll have y minus x times y plus y to the square. So if we integrated all z with respect to y, and we need to evaluate that between y equals to 1 minus x and y equals to 1 minus x squared times dx. So that will give us the integral from 0 up to 1. And if we now plug in for y, the 1 minus x squared, we'll have 1 minus x squared, and then minus x times 1 minus x squared, and then plus 1 minus x squared to the square. And then for y equals to 1 minus x, we have minus 1 minus x, and then minus x times 1 minus x, and then plus 1 minus x to the square times dx. And this will give us Now we simplify a little bit here, so we have the integral from 0 up to 1, and we'll have 1 minus x squared minus x plus x to the third, and then plus 1 minus 2x to the square plus x to the fourth. If we take the 1 minus x to the square and all to the square and expand that, and then we'll have minus 1 and then plus x minus x squared minus 1 plus 2x minus x squared times dx. And if we simplify here, we have that 1 with the negative 1 and the 1 with the other negative 1 cancel out. So we'll have that the integral from 0 up to 1 of, now we have an x to the fourth, and then we have plus an x to the third, and then we have for x to the square, we have negative 5x to the square, and then we have plus 3x times dx. And this is equal, if we integrate now, we'll have 1/5 x to the fifth for the integral of x to the fourth, and then we have plus 1/4 x to the fourth, and then we have negative 5/3 x to the third, and lastly we have 3/2 x to the square. And we need to evaluate all that between x equals to 0 and x equals to 1. So that will give us just 1/5 plus 1/4 minus 5/3 plus 3/2 for x equals to 1, minus 0 for x equals to 0. And if we take a common denominator of 60, we'll have 12 over 60 plus 15 over 60 minus 100 over 60, and then plus 90 over 60, which will give us 17 over 60. And this is in cubic units.